Hi, my name is Venkanna Kota. Now I want to discuss the problem of transmission lines. So here problem 1, a high frequency line has the following primary constants. L is equal to 1.2 millihenry per kilometer and C is equal to 0.05 microfarad per kilometer and R is equal to G is equal to negligible. Determine the characteristic impedance and propagation constant of the transmission line. So here note down this is high frequency line. At a high frequency or radio frequency, R value, G value both are equal to 0. So here in the given problem, primary constants are given. Primary constants L, R, G, C. These values are given. So here by using these four primary constants, we have to determine characteristic impedance and propagation constant of the transmission line. So for any problem, to solve the problem, first of all you have to write down the given data. In the given data, L is equal to 1.2 millihenry is given and millihenry which can be converted into Henry. Then 1.2 into 10 power minus 3 Henry per kilometer. And C is equal to 0.05 microfarad per kilometer. And it can be converted into farad. Then 0.05 into 10 power minus 6 farad per kilometer. So in the given value, R is equal to 0, G is equal to 0. By using these four parameters, we have to determine characteristic impedance and propagation constant. So here, first of all, we have to determine characteristic impedance, Z0. So Z0, first of all, in order to determine the characteristic impedance, we have to understand the formula. So formula depends on four parameters. That is Z0 characteristic impedance is equal to square root of R plus J omega L by G plus J omega C. This is the formula of characteristic impedance. In this formula, we have to substitute the given values. So R is equal to 0, G is equal to 0, we have to substitute. Then the equation becomes square root of 0 plus J omega L by 0 plus J omega C. J omega L by J omega C. So it can be written as square root of J omega L by J omega C. So J omega both are cancelled. The remaining value, characteristic impedance Z0 is equal to square root of L by C. So this is also this characteristic impedance equation equal to square root of L by C also equal to the characteristic impedance of transmission lines at radio frequencies. So in this given equation, we have to substitute the value of L and value of C. Then we get square root of value of L. L is equal to how much value? L is equal to 1.2 into 10 power minus 3. So here L is equal to 1.2 into 10 power minus 3 by C value. What is the C value? C is equal to 0.05 into 10 power minus 6. So 0.05 into 10 power minus 6. So after calculating this value, that is equal to Z0 is equal to 154.9 ohms. For the characteristic impedance, units are ohms. So this is the characteristic impedance equation. So once again I want to explain. So in the given problem, four parameters, these are primary constants are well given. So L value is given, C value, L value is given, C value is given, R value is given, G value is given. By using these parameters, we have to determine characteristic impedance and propagation constant. First of all, we have to solve the characteristic impedance. So characteristic impedance equation formula Z0 is equal to square root of R plus j omega L by G plus j omega C. So in the place of R, in the place of G, we have to substitute the given value 0. So that's why square root of 0 plus j omega L by 0 plus j omega C. And the equation becomes square root of j omega L by square root of j omega C. J omega both are cancelled. Then the value becomes Z0 is equal to square root of L by C. We have to substitute the L value and C value. Then the total characteristic impedance value becomes 154.9 ohms. Then we have to determine propagation constant value. Propagation constant. Propagation constant P is equal to the formula for propagation constant P is equal to square root of R plus j omega L into G plus j omega C. This is the formula for characteristic propagation constant. P is equal to square root of R plus j omega L into G plus j omega C. In the place of R and in the place of G, we have to substitute 0 value. Then it becomes square root of 0 plus j omega L into 0 plus j omega C. So then the equation becomes square root of j omega L into j omega C. So j omega into j omega. So j omega square. So then the equation becomes j omega whole square into L into C. So j omega square root both are cancelled. So that's why j omega out of from the root value. Then j omega square root of L into C. So in this equation, this is the propagation constant. In this equation, L value and C value we have to substitute. Then propagation constant P is equal to j omega into square root of L value. What is L value? 1.2 into 10 power minus 3 into C value. What is the C value? 0.05 into 10 power minus 6. So after calculating this value becomes P is equal to j omega into 7.745 into 10 power minus 4. So then the equation becomes P is equal to j of 7.745 into 10 power minus 4 omega. So then this is the propagation constant value P, propagation constant value. So here once again I want to explain. So propagation constant P is equal to formula for the propagation constant P is equal to square root of R plus j omega L into G g plus j omega c. Then given value in the problem, given value r is equal to 0, g is equal to 0. So we have to substitute the r is equal to 0, g is equal to 0 in this equation. Then we get 0 plus j omega, square root of 0 plus j omega l, 0 plus j omega c. So then the equation becomes square root of j omega l into j omega c. So j omega both are square. So then the equation becomes square root of j omega whole square into LC. So square cube root 2 both are cancelled to each other. So that's why j omega out of the coming out of square root. That's why j omega into square root LC. So we have to substitute the L value and C value. L value is equal to 1.2 into 10 power minus 3 and C value is equal to 0.05 into 10 power minus 6. Then after calculating this value becomes 7.745 into 10 power minus 4. So then the propagation constant P is equal to j omega into 7.745 into 10 power minus 4. Then the equation becomes P is equal to j of 7.745 into 10 power minus 4 omega. This is the propagation constant value. So here for more classes and daily updates, for daily classes, subscribe my channel. My channel name is Electronics for Gate Kota Venkana. Thank you.